Hi, my name is Ross, and in this video I'd like to go over what an exponent is. In other countries, these are called indices or an index, and we'll go over why that is. And I'd like to go over a representation for exponents that works really well for going further on with fractions and logarithms and calculus. Don't worry if you're just starting out. We're not going to be going over calculus or logarithms. We're just going to stick to multiplication and division. But we are going to talk about a sequence representation that is useful for both basic and advanced exponents. And let's not forget, we're going to go over some examples. All right. So an exponent or an index, we're going to call them exponents from here on out, is a way to turn your multiplication and your division back into addition and subtraction. So it's a really handy way to where if you can count the exponents easily, you can just do the addition subtraction of exponents instead of thinking about all the multiplication division directly. So that's one really good use for exponents. And then a couple other things are that they're used in studying interest rates, growth and decay rates for living systems, or like radiation. They get used in signal processing. They're used all over the place in physics and engineering. So that's the utility of learning them. I almost forgot. An index is a number used to reference some other number or some word on a page in a book, or it's used to order your data. And so it's just some sort of number you're using to reference some other thing. So for us, in terms of exponents and indices, many index, an index is a number that references this other number in your multiplication or division based on that base number you're using that we talked about it. Okay, let's get back to the video. But let's go over some examples so you know how to work with them. Okay, so here we have, as you can see, 2's to a bunch of powers. So exponents, indices, they're also called powers. And so all that means is that you're keeping track of how many you're multiplying. So the first answer here is just 2. So that's the base. And we're going to use the word base a bunch for exponents, especially when we move on to logarithms in a future video. So 2 squared is 2 times 2, and that's 4. And so the nice thing now is that you can say, well, 2 cubed is 2 times 2 squared. It's that 1 plus that 2. So let's go ahead and show that directly. And that would be 2 times 4, so that's just 8. And then you do the same thing. Oh, you say, oh, this is 2 times 2 cubed. Oh, well, that's got to be 2 times 8, so that's 16. And then 2 to the 5th likewise is 2 times 16, and that would be 32. So that's kind of the way you use them if you're just purely multiplying. And you can see how oh, yeah, that is, you are just adding. So let's do it with 3. So once again, the number here's the base is 3, and 1, we usually don't really write the 1. And that's just, shorthand, just to be quick. So you always have the base number. That's really important. And then you say, well, what's 3 times 3? Oh, well, that's 9. And you say, okay, what's 3 cubed? Well, it's got to be 3 times 3 squared, so it's 3 times 9, and that's 27. And then here you can just right away, if you know 3 squared, you can just say, oh, it's 3 times 27. And that one you might have to do yourself. It's going to be 60 plus 21. So that's 20 times 3 and 7 times 3, so it's 81. So that's how I do my multiplication. And then 3 to the 5th, let's give ourselves a little bit more room here. 3 to the 5th is 3 times 81. So just to show it, that's 3 times 80 plus 3 times 1. And so that is going to be 243. So just a little review on some multiplication and addition. Okay, so let's go ahead and get to what I call the sequence representation of the base number. So I want you to think about the base as you choose the base. So base, you can use like A or B as a symbol. I'm going to use B just because B is base, right? So the idea here is that you're now we're getting into a little bit more like the pre-algebra side in a way to think about this that'll really help. So you don't have to worry about that symbol B. I think it's good to start really thinking about that now. So you always have your baseline, right? Baseline. So 1 means the base. And then you multiply more on. So 2 times 2 is 4. 3 times another 2 is 8. So on and so forth. But now we need to go the other way and start talking about division. And so now when you go backwards, you're subtracting the exponent or you're dividing. So let's use another color. We can use an orange. So when you go backwards, you're dividing by the base. So then the answer you get is 1. So let's go over that. So 2 to the x is now a placeholder. So I'm throwing some algebra concepts, and I think that's just good. So now let's go backwards. So now we're going to be dividing by 2 as we go backwards. So we have the exponent, x for the exponent, and then the base raised to that exponent or index or power. So 2 to the x, or b to the x. So if you divide by 2, you get 1. So 2 to the 0 is 1. It's kind of interesting. Well, now we can go into negative numbers. So, I understand that this might be a little bit of a stretch for some people. So now you can go backwards. You can say, what if I want to divide? So 2 to the negative 1 is 1/2. And then you divide that by 2 again, and you get 1/4. You divide that by 2 again, and you get 1/8. And then so on and so forth. So the next one, 2 to the negative 4th, is 1/16. So see how the negative here is like, oh, I have a fraction, and I can just do positive exponents, or I can do everything is in the numerator and then negative exponents. So I know that was a little bit of a jump, but I think it's pretty important to go over that. Okay, so just to recap our pre-algebra sort of algebra mindset that carries on into geometry and calculus and all that type of stuff, and that gets written in textbooks. So you would write the general form of any exponent or using exponents as choosing a base number. So we did 2, and we're going to do 10 in just a moment, b, and raising it to the power or the exponent x. Some places say the base number a raised to the power x. So you might see b to the x or a to the x if you use books, or if you have a teacher that's teaching you this right now. So you have a base number and you have an exponent. And you just need to know what symbols are being used for your pre-algebra and algebra courses. Okay, so let's go ahead and do our sequencing for a base of 10. So 10 is the base. So if you go up, you're adding exponents. You multiply. So 10 times 10 is 100. Then 10 times 100 is 1,000. And then 10 times 1,000 is 10,000. Okay, so then you go backwards. Now we're subtracting, or we're dividing. So 10 divided by 10 is 1. So that's 10 to the 0 power. So this is 10 to the 0, 10 to the 1, 10 squared, 10 cubed, 10 to the 4th. That's a 2. And now we have 10 to the negative 1, or 1 over 10. So keep that in mind. Let's draw that a little cleaner, maybe. So this is 10 to the negative 1, or also 1/10. So that's why the answer is 1/10. So, okay. I think we're good to just keep rolling with it. 10 to the negative 2 is the same as 1 over 10 squared, so it's 1 over 100. Remember, we're dividing the previous number to travel either to the left. 10 to the negative 3 is 1 over 1,000, or 1,000th. So we have a 10th, 100th, 1,000th, and then we get 1/10,000th. And this is actually kind of the formal, sort of justification for place value. This is another way to represent place value. We're learning all sorts of things in this video. I should probably put a note. So now that we've gone over some of that sequence representation of how to understand what positive and negative exponents are and how they're really a simplification to handle multiplication and division, let's just do some basic, let's go over the properties, rules of exponents. So just the straightforward stuff or the not so straightforward stuff. So 4 cubed, we did 2 and 3 and 10. So it works for any base. You'd say, well, it's 4 times 4 times 4, or 4 times 4 squared. So that's 4 times 16. And let's try to be consistent with our notation, even though parentheses are a valid way to show multiplication in later classes. So 4 16s is the same as, 2 32s, because 2 times 16 is 32. And so that would be 64. So if you already knew that, that's fine. If you need to write out anything to show that, go for it. No judgment here. Okay, great. So now I want to showcase changing a fraction into the exponent representation. So 8 is 2 cubed and 4 is 2 squared. Now, I'm sure by this point in your math career, you've studied multiplication and division and fractions enough to where you feel comfortable saying 8 divided by 4 is 2 right off the bat. This is just a really simple example to showcase the utility of rewriting things in terms of exponents when they're numbers that you're not so comfortable with. So now you can say, oh, it's 2, 3 minus 2, and then you have 2 to the 1 or just 2. So remember, when you're writing the exponent, you're kind of that 2 to the 1 here. You're saying, I'm not done. I need to evaluate this still. And then when you write the number, you're saying, okay, we're done. This is what the answer is. So, a little bit of the process. Okay, so now, exponents can show up anywhere. So here, I've given you something already in exponent form. So let's go ahead and reduce it or expand it, depending on how you, not reduce, simplify. So 3 cubed is 3 times 9. So that would be 27. Minus 16 is 4 squared, 4 times 4. And then 27 minus 16 is 11. So there's many ways to write 11. Okay, so now let's kind of go over what I did in example 2, but let's now just work with multiplication. So here I have 6 squared times 12, and I can just write that as 6 squared times 6 times 2 if I'm more comfortable with that. So this one's gonna, so 6 squared is 36 times 6 times 2. 36 times 6, you might need to do this off to the side. There's no problems there. So, we have another 36. 6 times 3 is 18. Plus 3 is 21. So I like to cross it out when I've done my addition. And so that's 216 times 2. And then 216 times 2 is going to be 432. So see how we're scaling up, and that exponents can be used any which way. And you can rewrite your multiplication if you find it handier to factor or rewrite, in terms of different bases, and use your exponent rules. Okay, everyone. So after thinking about it, I think the bonus example is worth its own video because it does go over a lot of algebra content. And so just make sure you look for the next video that's about a pretty, a good introduction to how exponents are represented in algebra, as well as how we extend all the things we learned in this video to more of that symbolic, abstract version of mathematics that people tend to, struggle with or don't like just because it's so different to how we normally think. So make sure you look for that video coming up. So I hope you found that helpful. Please give us a like. And if you want to be notified when there's more videos like this, please hit that subscribe button and that bell icon. And we'd really appreciate it if you could leave a comment down below about which topics in math or physics or just science you want to know more about, as well as if you have any tips you want to leave for someone who's learning this as well. All right, so thank you for joining me, and I'll see you in the next video. Bye.